Hey guys, so we're going to look at lesson 4.2, solving quadratic equations by factoring. So by this time you should have practiced factoring and spent yesterday doing that. But now we're going to take it further and show you how to, from factoring, be able to solve a quadratic equation. So what your steps are is you're first going to factor it first. Okay. Get your two brackets that equal 0. So for example, if I had x squared plus 2x plus 1, that would factor as x times x gives me x squared, and then x plus 1 and x plus 1 multiplies to positive 1 and adds up to positive 2. So it multiplies to 1, adds up to 2, and that's how I know I'm doing it properly. So these two factors are equal to 0. So we're going to do something called the product rule. So the zero product rule. So let's say I have a and b equaling 0. That means that a could equal 0 or b could equal 0 or both could equal 0. Because if a is equal to 0, the whole thing becomes 0. Or b could equal 0 and make the equation equal to 0. So that's what we're going to do. We're going to take each factor, x plus 1 and x plus 1, they're both the same, make them equal to 0. And then what you do is you bring that positive 1 to the other side and you make it equal to negative 1. Same thing here, positive 1, you bring it over and it becomes x equals negative 1. Now, since they're the same answer, you only write the answer once. So that is the solution to the factors or the factored form. So your answer is x equals negative 1. That means these are answers that would make either the first factor or the second factor equal to 0, which would make the whole equation equal to 0. This is your x-intercept. So if I were to graph this, and I'm going to just confirm that, if I were to graph that, you should see that the graph touches the x-axis at x equals negative 1. So let's go x squared. So this is just a way of checking using the graphical method that we learned in lesson 4.1. Add 1, graph it, and you should see that it touches the graph at x equals negative 1. So like we said. Example number 1, we're going to work on factoring each of these. So this, you always need to take out the greatest common factor first. So if you ever see something in common, take it out by factoring it out. So I'm going to divide both of those values by x and it goes in front. So that leaves me with x minus 11 equaling 0. So this is a factor and this is a factor. You're going to make each factor equal to 0. And then this one is already solved for x, so you don't have to do anything there. But this one, we're going to have to add 11 on both sides to get x alone, which means that 0 plus 11 is 11, so x could also equal 11. So these are the two solutions or two x-intercept to the equation. Over here, we're going to take out the common value, so they both can be divided by 5, both terms, and they both have an x in common, so you're going to divide out the x. That leaves me with 2x plus, and then anytime you take out all of it, that's like saying 5x divided by 5x, you should always have a 1 in that spot. So don't forget to place that 1 if you remove all of it by dividing out exactly what you see. So 5x divided by 5x is 1. So you have now the two factors are 5x, that's in front, that's a factor, and what's in brackets, 2x plus 1 equals 0. So make each factor equal to 0. Now always do the opposite to get x by itself. Divide by 5, which means that 0 divided by 5 is 0. That's one solution. You're going to find that one x-intercept occurs at x equals 0. The other one, we're going to have to subtract 1 on both sides, which gives us 2x equals negative 1. And then you're going to have to divide both sides by 2, which means that x can equal negative 1 over 2. So if you ever see a number in front of x, you're always going to have to move the constant over. So the positive 1 becomes negative 1, and you're always going to have to divide by the number in front of x to get dividing by 2. So that's how you get that factor. Now we're going to go to that like common way of factoring. So The shortcut of doing this is I always try to find two numbers that multiply to the last and adds up to the middle, as long as there's a 1 in front of x squared. So I know that they're always going to have x times x to give me x squared. And then the two numbers that multiply to 24 and add up to a negative 11 would be negative 8 and negative 3. Because if you add them together, they do add up to negative 11 and they do multiply to positive 24. So we make that equal to 0, just like these ones. And then take each factor, once you factored it correctly, make them equal to 0. Which means that you're going to have to add 8 to both sides, add 3 to both sides, which means those cross off, leaving you with x equals positive 8 as one solution, and x equals 3 as the other solution. D, always take out the greatest common factor, so they can all be divided by 2. So you have 2 being taken out and put in front of the bracket, leaving you with x squared, because 2 divided by 2 is 1, you don't have to write it. Negative 6 divided by 2 is negative 3. X, and negative 56 divided by 2 is negative 28. So that's factored, partially factored. Now we need to break this up even further. The 2 still stays in front, but what you're going to do is say two numbers that multiply to x squared would be x times x, and we have to find the two numbers that multiply to this and add up to the middle, because there is a 1 in front of x squared. So the two numbers that multiply to negative 28 and add up to negative 3x would be, actually I don't need the x in this shortcut, it would be negative 7 and positive 4. So negative 7 and positive 4, if you were to multiply them, they get you negative 28, and if you were to add them together, you get negative 3. Once you have it factored, you only have to take the factors. Now, these are all factors, but you only have to solve for the factors that have variables, meaning letters x's. So we're only going to take this one and this one, make them equal to 0, which means that x equals, move the negative 7 over, it becomes positive 7. And x could equal negative 4, because you move over the positive 4, it becomes the opposite sign. So those are our two solutions to the quadratic equation. Whenever they give you something like this, you need to move it all to one side. Okay, so I moved over the negative 8x and the positive 16, because ideally you always want x squared being positive. So again, this is the shortcut. I'm taking two brackets. X times x gives me x squared. You have to find the two numbers that multiply to 16 and add up to 8. So that would be 4 and 4. So I would get that x equals negative 4, because if you take this one and make it equal to 0 and this one and make it equal to 0, they both give you the same answers by bringing positive 4 to the other side. So there's only one solution. That means the vertex touches the x-axis at negative 4. Now, F is a special case. These ones are called difference of squares. The reason they're called a difference of squares is because they have a subtraction between them. So that's step 1. And these are both perfect squares, meaning if you can square root x squared and you can square root 36 to get the actual factors that equal it. So for example, the square root of x squared would be x and x. So x times x gives me x squared. The square root of 36 would give me 6 and 6. And to get that negative value, you would have to have a positive and a negative between them. And this is always equal to 0. So this is how you factor a difference of squares. This is the shortest, fastest way to do it. So you square root the first value, that gives you the first terms. Square root the last number, that gives you your last terms. Always you should have a plus and a minus between the actual values. So that means that x plus 6 equals to 0 and x minus 6 equals to 0, which means that x equals negative 6 when you bring it over, and x equals 6 when you bring it over. So we can write it as x equals positive negative 6. Example number 2. Determine the roots of the following quadratic equation. Roots is just another way of saying solve for x, but we have to do it by factoring. So again, move everything to one side. Always make sure one of the sides equals 0. Make 2 brackets equal to 0. X times x gives me x squared, and you have to find 2 numbers that multiply to this and add up to this. Those are the numbers inside the bracket. They should be -8 and -2, which means that x minus 8 equals 0, and x minus 2 can equal 0. X can equal +8, and x can equal +2. So those are our 2 solutions. The next one is where we get into the specific kind of strategies. We can use box method. For me, what I find is the fastest method is I do this like fraction kind of strategy. But if you like box method, what I'll do is I'll do it one method, I'll erase it, and I'll do the other 2 methods just to show you that it works and you'll get the exact same answer. So I'm going to actually do example number B using those different methods, and you can choose what you prefer. So step 1, let's say I'm going to do the fraction method. So if you like the fraction method, what you would do is you'd always multiply your first and your last term together. So these 2 need to multiply together, even the variable. So I would have 3 times -14 gives me -42. So I have to find 2 numbers that multiply to -42x squared. So that's the first and the last. That's how I got that. And it always has to add up to the middle, meaning +19x. So the 2 numbers that I have to figure out that work for both would actually be, so this is where you have to practice and get confident with finding those numbers. So the 2 numbers that work would be 21x and -2x, because it works for both the first and the second line. Once you find that, you write out the first term twice, meaning 3x squared, you write it out twice. So you're going to divide it by the 2 numbers I just found, which would be 21x and -2x. Now you're going to simplify it. Well, the number should simplify and the variable should simplify. Same thing here. Number simplify, variable simplify. So 3 and 2 don't simplify any further. Oh, sorry, it should be 3 and 21. Cutting that off a little bit. 3 and 21 do simplify because you can divide the top by 3 and the bottom by 3. So that leaves me with x squared over x, which is x. And then 3 divided by 3 is 1. You don't have to write it. 21 divided by 3 is 7. And x squared over x, you don't have an x at the bottom anymore because it crossed off an x from each the top and the bottom. So that would be your first fraction. The second one, the 3 and the -2 don't change. But the x squared and the x do simplify to just 1x at the top. So those are your factors. So our factor is x plus 7 and 3x minus 2. And then you're going to go further by making each one equal to 0, just like before, which means that x equals -7 as one solution. And x equals, move the 2 over, it becomes, instead of -2, +2 over 3 is your second solution. So those are the 2 solutions. So that's fraction method. So that's like a made-up method that kind of I've worked on and I've seen before, and I really like that one. But now I'm going to show you box method. Okay, so we create a box. The first term goes into your first box. The last term goes into your bottom right box. And then, just like before, we still have to multiply your the first term together, and they have to add up to the middle. So you still have to find 2 numbers that multiply to 3, So you still have to find the two numbers that multiply to these, so that we already said that it was minus 42x squared, and they still have to add up to the middle, which is positive 19x. So we already found those numbers as 21x and negative 2x. And then what you do is you take those numbers and place it in these boxes in any order you want. Okay, and then our next step is to figure out what side lengths we should have for the box. Well, we're saying what times what gives us 3x squared. Well, let's say I know that 3x times x gives me 3x squared. Well, what if I put a 3x here? Will that work for this box? Well, no, because 3x times something here doesn't give me negative 2, so I can't put the 3x in that spot. Okay, so I have to put 3x here and x times here to multiply to 3x squared. Which means that to get this positive 21x, I'm going to have to multiply by positive 7. So 7 times 3x gives me 21x. So I already have one bracket. So that matches this guy right there. And then x times something has to give me negative 2x. Well, negative 2 times x gives me negative 2x. So there is your last bracket. Now you just confirm that negative 2 times 7 gives me negative 14. It does. So there's your second bracket at the top. Okay, so there's your one bracket, there's your second bracket, and then you just go on to solve like any other example. So that's your box method. And finally, decomposition. If you want to use that one, you can. So I'm going to write 3x squared. Remember, we still have to multiply your first and last and then add up to the middle. And we found that the numbers were 21x and minus 2x. So we're going to rewrite that 19 with the two numbers that still add up to it, but are multiples of the 3x and the negative 14. So the 3x squared and the negative 14, they did multiply to that. So that's where we get that from. And then what you do is you put brackets around your first two terms, brackets around your last two terms. And then you're going to factor out the greatest common factor. So for example, here I can take out a 3 and an x from the first bracket, leaving me with x plus 7. The second bracket, what's common is a negative 2, leaving me with x plus 7. How you know you did this properly is if these two brackets are identical. They are identical. If they are, then your factors come from the numbers in front. That creates one factor, so 3x minus 2, that's the circled red. And then your double bracket is your other answer. You just simplify it as one single value, and that is matching what we did before. So that's decomposition. Question C, this is the greatest common factor. Take out the x that's in common, leaving you with x plus 8. And that's equal to 0. So we know that x is one factor, x plus 7 is another factor, so you make them each equal to 0. So I have x equals 0 as one solution and x equals negative 8 as the other solution. Question D, this is that difference of squares. I know it's a difference of squares because both of them, if I square root them, will give me perfect whole numbers, and there's a subtraction in between. So if I take the square root of x squared, I'm going to get x and x. Those are the two first terms in the bracket. The square root of 81 is 9 and 9. And you should always have a plus and minus in between for it to be fully factored. So x equals positive, or actually negative 9 from the first one, and x equals positive 9 when you solve for x for the second one. So those are your two solutions, which we usually like to write it as plus minus 9. So that becomes this. Challenge question. Well, I could solve this by just isolating for x, but what I want to show you is how to do the factoring. Well, what I would do is write out the x minus 2 squared, because that's what that really means. I would do FOIL. So I would go x squared plus 2x minus 2x. Oh, it should be actually both of them minus 2x's. So first, outside, inside, last. And then minus 25. Once I do FOIL, I can subtract the 25 from it. So now we're going to join together these guys because they're like terms, and these guys because they're like terms. So I have minus 4x. And I have 4 minus 25 is minus 21, equaling 0. And now I can factor this. 2 brackets. Remember, we have to multiply 2 numbers that give me x squared, which is x times x. And the 2 numbers that give me negative 21 are negative 7 and positive 3. That means that x can equal 7 and x can equal negative 3. Those are your 2 factors. Example number 3. So again, we're going to use here either box method, decomposition, or the fraction method. I'm going to use the fraction method, but you can use whatever method you want to break it up as long as you get the same answer as me in the end. So I'm going to use the fraction method by multiplying 6 times negative 15 first. And that's going to give me negative 90. So I have to find 2 numbers that multiply to negative 90x squared, actually, and adds up to the middle, which is positive 1x. That means the numbers have to be like right next to each other. So the only way that's possible is if I have 10x multiplied by negative 9x. So those are the 2 numbers that work for both rows. So they will multiply to negative 90x squared and add up to 1x. So what I do is I write out the first term twice and divide it by the 2 numbers I just found, which was 10x and negative 9x. Now you simplify the numbers and then you simplify the variables. Same thing here. Simplify the numbers, simplify the variables. 6 and 10 simplifies to, you can divide them both by 2, which gives me 3 and 5. And x squared over x always just gives me x. And then same thing here, 6 and negative 9, they can both be divided by 3, which gives me 2x over negative 3. And then x squared over x gives me just that x that I wrote. So that's your factors. 3x plus 5 is one factor. 2x minus 3 is your other factor, equaling 0. So when you solve, x equals, you always bring this guy over to become negative 5. And then you divide by the number in front of x, which is 3. Here you would do the opposite. So instead of subtracting 3, we add 3 to the other side and then divide by the number in front of x, which is 2. Those are your 2 solutions. Question B, we want to factor out the 1/4. We don't like fractions, so we like to take them out by dividing everything by 1/4. So we're going to divide everything by 1/4. A trick to that is we're going to actually multiply by the reciprocal, which is the flip of that number. So instead of dividing by 1/4, we're going to multiply by just 4. That means the exact same thing as dividing by 1/4. So that means you're going to be left with x squared, because when we multiply a 1/4 by 4, it becomes 1. And then we're going to have negative 4x, because negative 1 times 4 is negative 4x. And then negative 3 times 4 is negative 12. So that is factoring out the 1/4. The reason I do it is now this becomes way easier to factor when I don't have fractions in it. Well, this part, you're going to say x times x gives me x squared. And then the 2 numbers that multiply to negative 12 and add up to the negative 4 are negative 6 and positive 2. So that means that you only look at the factors that have variables. So that means x could equal positive 6 because it's the opposite sign of what you see. And x equals negative 2 as your solutions. Okay, so for the next one, what I would do is I would do something called replace. So this is a really handy technique, especially once you get into 30-1 when it gets really complicated. You're going to take something out to make it easier to work with, but then you're going to put it back in. So for example, I may take a plus 2 and replace it with b, the letter b. So everywhere you see an x plus 2, because that's in common, you're going to say b. So I'm going to write b. So that replaces this, but you still have the squared there. Plus 3, but instead of a plus 2, you're going to write a b again. And then plus 2 equals 0. The reason I did that is that this is nicely factorable. You can write out two brackets that equal 0. B times b equals b squared. Two numbers that multiply to 2 and add up to 3 would be positive 2 and positive 1. So that means that b equals negative 2 and b equals negative 1. Okay, so far we had those two solutions. But we want to solve for a, because remember, a plus a is what we started with. We should have the same variables in the very end. So now you're going to replace b back with a plus 2. So wherever you see a b, meaning a plus 2, so b became a plus 2, and then that equals negative 2. Instead of b equals negative 1, you're going to have a plus 2 equals negative 1. Now all you have to do is isolate for a by bringing this over and this guy over. So a is equal to negative 2 minus 2. A is equal to negative 4 then. So that's one solution. Here you're going to subtract 2 on both sides to get a by itself, which means that a is equal to negative 1 and minus 2, which is negative 3. There's your second solution. So this is a method of replacing the a plus 2 with a variable, solving for it, and then going back and putting it back in to solve for the actual variable you want. D, difference of squares. Okay, so we're going to have to square root the first value, square root the second value. The square root of 16x squared is 4x in both brackets. The square root of 121 is 11. And you're going to have plus, minus in between, and those are your two factors. So that means that x can equal, you have to take this number, becomes negative 11, and divide it by the 4 in front of x to get one answer. And then x equals positive 11, because the opposite sign over 4 is your other answer. So x equals positive negative 11 over 4. Question E, similar to what we did in example E from the previous question, we're going to write out x plus 1 twice. And then we're going to distribute the 5 and then subtract 80. So 5, and then FOIL would be x squared plus 1x plus 1x plus 1 FOIL. And that will simplify as x squared plus 2x plus 1 minus 80 equals 0. Now we're going to distribute the 5 into all the parts. 5x squared plus 10x plus 5 minus 80 equals 0. So 5x squared plus 10x, and then we're going to put together the like terms. The 5 and the negative 80 becomes negative 75, equaling 0. And now we're going to take out the greatest common factor. So this is where we get into the factoring part. So we're going to take out the 5 that's in common, leaving me with x squared plus 2x minus 75 divided by 5 is 15. And that is equal to 0. Now you want to factor this by finding two numbers that multiply to negative 15 and add up to positive 2. So that would be x times x gives me x squared. And then we have positive 5 and negative 3 multiplies to negative 15, and also adds up to 2x, or 2. Okay, so those are our factors, which means that these two factors, the ones that have x's, will be x equals -5 and x equals +3, the opposite sign of what you see. So those are your two answers. Now we want to write a quadratic that matches this. Well, we're going backwards now. So we know that x equals -6 and x equals 3. Remember, when we want to bring it to the other side, switch the signs. That means that one factor is x plus 6, and the other factor from here is x minus 3. Now you just have to do FOIL to bring it back to the quadratic equation, and we just have to make it equal to 0. So that will be x squared. First, outside would be -3x, inside +6x, and last would be -18 equaling 0. X squared, we want to combine our like terms, so it's going to be +3x minus 18, and that's equal to 0. So this is our quadratic equation that matches our solutions. Example number 5. Find the lengths of the two unknown sides of a triangle if the hypotenuse is 15 centimeters long and the sum of the other two legs is 21 centimeters. So we have a right triangle here. They're giving us the hypotenuse, which is 15 centimeters long, and they're telling us that this and this, meaning plus, the sum is equal to 21 centimeters. So we know that x plus y equals 21. Now, whenever we're trying to solve for something, we should only have one variable. So I ideally want just an x. So what we're going to do is replace y. So solve for y. Y equals 21, take away x, because we're going to move that x to the other side. So this is an equation that replaces y. So we're going to write that y is 21 minus x. So in order to relate all these sides, we're going to use Pythagorean theorem, which means that x squared plus 21 minus x, that's your y, squared, equals 15 squared. X squared plus, we're going to write this out twice, equals 15 squared, and that's 225. Now we're going to do FOIL here. So that's going to be x squared plus 21 times 21 is 441 minus 21x. That's going to be also minus 21x for your, so that's your first outside, inside now, 21x. And then your last term is positive x squared, because negative x times negative x is positive x. And that's equal to 225 still. Now we have x squared. And there's two of them. We're going to start to join together the like terms. So that and that can go together to become 2x squared. These guys can go together as minus 42x. And then we still have this positive 441 equals 225. Now, if we want to make this an equation, we have to bring this over so that we have a 0 on the right side. So we have 2x squared minus 42x, positive 441, subtract 225, that's what we're actually doing, will give me positive 216, and that's equal to 0 now. We want to start by factoring out the greatest common factor, which is a 2. So divide everything by 2. And now we want to find two numbers that multiply to 108 and add up to -21. So that will be x minus 12 and x minus 9. So that means that x can equal positive 12 or x can equal positive 9. So what that means is those are your two dimensions. If you have, going back to this triangle, this side is 12, then 21 minus 12 gives you 9. So that'll be your other side length. Or if this side equals 9, the other side length will be 12. So that's what they mean. They're interchangeable. The legs can switch. These are the legs. Don't forget to put that there in centimeters, and that would be your answer. Example number 6. So example number 6 and 7 are very similar. So these are common questions that you'll see a lot of. So let's look at example number 6. A factory is to be built on a lot that measures 80 by 60. So we have a lot. So I'm going to draw a big rectangle with the measurements 80 meters by 60 meters. The lawn, so there's some grass around this factory that we are going to use. That's going to be the same area. So all this area around here, we're going to call this A, is going to be equal to the area in B. Okay, so A is equal to B in area. How wide is the strip of lawn? So we have this strip of lawn that we will call X surrounding it. So it's going to be equal in width all the way around. We have this X surrounding it on every single side. So we need to figure out it says, what are the dimensions of the factory? So let's figure out the area of the factory. Area of a rectangle is always equal to length times width. So the area of the factory will actually equal the original lot, 80, minus, now we're taking off the grass. We have X and X grass that is surrounding it. So we're going to have to, from 80, take off this X and this X to get the dimensions from here to here. So that's going to be subtract 2 X's. Now we're going to have to do the same thing for the width. We have 60, and again, we are taking off this and this from that 60. So 2 X's are also being subtracted from the 60. The area, we have to look at the original area, which was equal to 80 times 60. If we multiply them, we get 4,800. And that will be in meters squared. Now we know that the lawn and the factory are equal in area, and that's what the actual lot is made of. So we need to divide this by 2 because it's equally shared amongst the lawn and the factory, and that gives us that the factory is half of 4,800, which is 2,400 meters squared. So that's what we needed to figure out, is what the dimensions of the factory were. But we need to still solve for X. So now we're taking this and using, we're expanding it until we get into standard form. And once it's in standard form, we can factor it and solve for the answer for X. So we're going to have 2,400 equals FOIL first, outside, inside, last will look like this. 80 times 60 is 4,800. Outside is minus 160x. Inside would be minus 120x. And last would be positive 4x squared. Let's put it in standard form by bringing everything to one side. So it's going to be positive 4x squared. These two guys will combine to give me negative 280x. And then we'll have the positive 4,800 and then the minus 2,400 because we're moving that left side over to the right side. And so our equation that we're going to have to factor will be this guy right here. Okay, so we're going to start by factoring out the 4 because it's the greatest common factor. So I'm going to divide everything by 4. And now we can say 4, and then the two numbers that multiply to x squared would be x times x, and what multiplies to 600 and adds up to negative 70 would be negative 6 and negative 10, which means that x could equal 60 or x could equal 10. Now, x represents the width of the lawn that we are surrounding the factory with. Now, we cannot have this as an answer because if I put 60 here and 60 here as the lawn, that will be more than the width that I actually have. So if I put 60 on both sides for the lawn, that means that it's gone over the width of the actual area, the lot. So this is not possible. That's that extraneous solution. So the only answer is that I can have a strip of lawn being 10 meters. So this is the strip of lawn, and the dimensions would be going 80 minus 2 times 10, which would be 80 minus 20. So one dimension is 60, and then the other one is 60, take away 2 times 10, which is also 20, taking off of 60, 40 meters. So this is my answer for the dimensions. I can have a factory that is 60 by 40 for this all to work. Example number 7 is similar. They're giving you a picture that is 30 centimeters by 20 centimeters. And what you're trying to do is go outwards. They're giving you a frame, but they're not telling you what the dimensions of the frame are. And that's what you need to find out. The dimensions of the entire frame picture and how wide the frame is, which is X. So there's going to be this frame that goes around the entire picture equally. Okay. So we are going to start by writing the area of the frame and the picture is equal to, so it's going to be 30 plus 2x again, because we have this x surrounding that picture, and 20 plus 2x. Now, just like before, we know that the picture is equal to an area of 30 by 20, so that equals 600 centimeters squared. We also know that the frame is of uniform width and equal in area to the picture. So if we double this, we're going to get the picture plus the frame dimensions, or area in this case. So if we double it, we get 1200 because the picture is 600, and it also tells us the frame by itself is supposed to be 600 centimeters squared as well. So now I can fill it in by doing FOIL. So we have 600 first outside, inside, last. Bring everything to one side. We have 0 equals 4x squared. Then we're going to have plus 100x when we combine these two terms. We have plus 600 minus 1200. 0 equals 4x squared plus 100x. And then when we combine them, we get minus 600. Now we want to factor. So we want to take out the 4, which is called taking out the greatest common factor. We have to find two numbers that multiply to this and add up to the middle. So that would be x times x gives me x squared, and the two numbers that work would be positive 30 and negative 5. So that means that x could equal negative 30. Now we can't have a frame that has, we can't have a frame that is negative 30 centimeters wide, so this one doesn't make sense. But the x equals 5 centimeters does make sense for the additional, for the frame width. So we now know that how wide the frame is. So this is the width of frame. And the dimensions, we need to make sure we answer all the questions, would be in this case, going back here and saying 30 plus 2 times 5, that'll be one dimension. And then the other dimension would be 20 plus 2 times 5. So this will be 30 plus 10, and this will be 20 plus 10. So our new dimensions will be 40 centimeters by the 20 plus 10 is 30 centimeters. So that's our final answer. Okay, so that would be our lesson on 4.2. So this is a really, really, really important lesson. Make sure you master this, and then seek me out for help if you don't know how to factor or you're having trouble factoring, because this would be the number one thing that you need to go into